Alright, so today we're going to be taking a look at circles. Now in this video, I'm going to examine some of the special properties of a circle. And I'm not going to cover all of the theorems or all of the known properties, but we're going to take a look at some of the interesting consequences of a circle's properties. So let's say I start off with a small circle, 3 centimeters radius. Okay. So I've got my circle right here, and one of the things we notice with the circle immediately is that it has a radius. Now the radius is half the total length of the circle, right? It's half the diameter. Now what if instead of one radius we have 2 radii? Now we know that these 2 radii are equal to each other, because they both start from the center of the circle and they stretch out to the to its circumference. So we're going to put these lines that show that the length of this radius is exactly equal to the length of this one. And that's gonna help us in future problems, but maybe not this one. Who knows? Another thing you notice immediately is that this radius, these 2 radii have a common vertex right over here. That common vertex is the center of the circle, and we're gonna call it O for now. Now, this common vertex also shows that these 2 radii form an angle, and this angle happens to subtend this arc. What do I mean by subtend? Well, let's find out. A, B. What I mean by subtend is that this angle, O, at the center of the circle, cuts off this arc over here. And of course an arc is a part of the circle's circumference, right? So we can write this by saying our central angle O, and we say central because the vertex is, of course, at the center of the circle. Central angle O subtends arc AB. Right? Now, one of the things you immediately notice is that this angle right here has the vertex at the center of the circle. But what if it didn't? What if this vertex were at the edge of the circle, at its circumference? Well, let's take a look at the consequences of that. So let's say I have okay, so I have my second circle right here, and my second circle right here is going to have an angle that has a vertex at the edge or at the circumference of the circle. But just like our previous angle, which had a vertex at the center, this angle also subtends or cuts off an arc, a part of the circle. Okay? Now, arcs can be measured in 2 ways. We can measure it in form of their length, so how big is this, or we can measure it in terms of its rotation by using degrees. So let's say this angle has an angle measure of 30. Okay, 30 degrees right over here. So now this arc has a measure of 30 degrees. Instead of calling it this arc, I might as well name it arc AB and angle O. Now this arc has a measure of AB, so we're going to say arc AB equals 30 degrees. Now, if arc AB is 30 degrees, what is the measure of angle O? Well, it turns out that no matter where this angle, what part of the circumference this angle O lies on, it's always going to have a measure of theta over 2, meaning the measure of this angle O will always be half of the arc that it subtends. So theta here is the measure of the arc. So theta is going to be 30 over 2, or 15 degrees. So the measure of angle O is going to be 15 degrees. Whereas, if instead we had the vertex O at the center of the circle, like this, but subtending the same arc, then angle O would have a measure of 30 degrees. So what's the moral of our story right over here? Well, at the end of the day, what do we end up with? So at the end of the day, what we end up with is an inscribed angle let's say we have this inscribed angle right here, and it's subtending this arc that you can clearly see, and so what you can clearly see here is that this angle is subtending this arc, and we're going to have another angle. Oh, whoops. And we're going to have another angle that has a... Okay. So now what you see right here is that if this angle, this arc, has a measure of theta degrees, the central angle will also have a measure of theta degrees, whereas the inscribed angle over here, that's inscribed on the edge of the circle, will have a measure of theta over 2 degrees. Okay, so that's the moral of our story. Now let's move on to another interesting property of circles. For this one, we're going to note, what if our inscribed angle was instead outside of the circle? Now, this is going to be quite interesting. So let's begin with our circle. Our circle right here will have its center O, and it's going to have an inscribed, well, not inscribed actually, because it's not within the circle anymore, but we're going to have an angle outside of the circle, like this one. Now let's call this angle K. Now what would the measure of K be? How many degrees? Well, it turns out the measure of K would be, well, to find the measure of K, we have to find the arcs that this angle subtends. So it turns out that this angle right here actually subtends 2 arcs. This arc right over here, and this arc on the circumference. So now both arcs, let's call this arc, let's say this arc has a measurement of A degrees, and let's say this arc, this larger arc, much larger, has a measurement of B degrees. Well, what we would say the measure of angle K is B degrees minus A degrees divided by 2. So it's going to take the difference of the two arcs that this angle subtends, and we're going to have it. That's all that this theorem states. Alright, now instead of having an angle outside the circle, let's say we had a line outside the circle. Well, how would that line have anything to do with the circle? Well, it would have to be tangent to our circle, correct? So let's begin with the circle. Our circle right here is going to have a line tangent to it, and we're going to call this line AB. Now, let's say this line has an angle. What would be the measurement of this angle? Well, let's first take a look at what arc this angle subtends. You're always looking for parts of the circle that these figures within it or outside of the circle interconnect to, and you can use those figures and the relationships that come along with them to figure out the answer to many geometry problems. So let's take a look. This angle measure right here will actually involve this arc that is subtended by the angle. So let's say the measure of this arc right here is theta. Thus, the measure of angle AKC. The measure of angle AKC will be theta divided by 2 degrees. Okay, so that right there is the third theorem we've done. We've taken a look at what would happen if you had an inscribed angle. What would happen if you would have an angle outside of our circle? And what would happen if you had a line tangent to the circle instead of having an angle? Now, let's take a look at another interesting property, shall we? Let's start off with our standard circle. Now this circle right here, this circle will have something we call a chord. Now what is a chord? Well, in music I'm not sure what it is in music, but in geometry, a chord is any line in a circle that goes from one part of the circumference to another. For example, the diameter is a chord, but the radius is not, because it does not stretch out to the opposite side of the circle. Now, let's take a look at these two intersecting chords, shall we? These chords are not parallel, they're intersecting. And so what would we say that the measurement of this angle is? Well, let's pretend we don't know yet. So what would the measurement of this angle be? Well, first of all, we know that since these are vertical angles, this angle will have the same measure. But that doesn't really help us, does it? Well, what if we said this angle had a measurement of 180 minus whatever these angles were? Well, that doesn't help either. We just need to find out what this angle is, first of all. Well, we can do so by once again looking at the arcs that the angles subtend. So since we have two chords, the two chords form an angle, and we can take a look at the arc that these angles subtend, which I've highlighted in pink for you. Now, let's call the measurement of this arc A, and let's call the measurement of this larger arc B. Of course, realize that sometimes these two arcs will have equal measures, and most of the times they'll have different measures. That doesn't concern us. What we need to find out is the degree measure for this vertical angle. Well, we can do so by adding by summing up the degree measure of our two arcs that are subtended by this angle. And once we add them, we simply divide by 2. Okay? And that's the magic of it all. You have two chords. These two chords form an angle, and you look at the arcs that these angles subtend, and you find their average, and that's it. You suddenly know the value of this angle, and you also know the value of all the other angles adjacent to it and vertical to it. So those are some of the interesting properties of a circle we've taken a look at. So thanks everyone for watching, and I'll see you next time. Also, as a thank you for the Art of Problem Solving community for taking a look at my videos. Stay tuned for more videos.